Well, good morning, everyone. Thank you for joining us for the 2025 Fall Research Day. I know our student presenters are really excited to share their work with you all. And we are going to go ahead and get started rather quickly. We are starting at 11, but our first presenter, Ms. Kaylor Scott, is going to share her screen now. Like I said, thank you all so much for coming to 2025 Fall Research Day. Again, here you can see our digital program with all of our presenters' names. So Kaylor, whenever you're ready, go ahead and share your screen and then we can start right at 11. And again, for those of you joining us in our audience, thank you so much for coming and taking time out of your day. We're really excited for you to hear about all the great research that is being done by our undergraduate students. We have a diverse group of students here presenting about, anything from psychology to AI to um, different topics. So to start us off, we have Ms. Kaylor Scott here. And Kaylor, whenever you're ready, go ahead and get started.
Hi everyone, my name is Kaylor Scott. Welcome to my presentation, Enforcement in Fact, Understanding Public Trust in the Police Across Latin America and the Caribbean. So I'm an international student and a senior majoring in political science with keen interests in democratic governance and international relations, especially within this region. And thanks to my mentor, Martin Gendor, the core idea behind this project is that public trust in the police is essential for democracy. But in many places, that trust is very fragile. So I'm asking, why do some countries in this region have lower and higher confidence in law enforcement? And what are the forces that drive this trust? So what we'll cover today, I'll be walking through four main sections. Firstly, I'll be getting into the research question. Then I'll share the theoretical framework and my hypotheses. Then I'll be sharing the data sources and summarizing key results. And then finally, I'll be wrapping up with the conclusion and then the wider scholarship. So analysis of the research question. How and why does public trust in the police vary across Latin American and Caribbean countries? So many countries within this region have a long history of militarized policing, corruption, and violence. These legacies create complicated relationships between the communities and police forces. And because people often fear mistreatment or corruption, they'll report fewer crimes and cooperate way less with the police and with investigations. The result is ineffective policing, which in turn deepens mistrust and continues a cycle which undermines both safety and democratic stability. So I focused on three main factors which influence public trust. First, socioeconomic status and social class, looking at poor marginalized communities as opposed to wealthier ones. Second, countries that have and have not lived under military regimes and have lasting effects. And then finally, perceived police misconduct, measured through killings and legal interventions. Next, my hypotheses. So I proposed that lower socioeconomic status and social class would correlate with lower public trust. Countries with authoritarian or militarized histories would have a lower public trust. And then finally, where police misconduct or violence is perceived as high, trust also declines. For my data, I drew from several major data sets, including the Latin American Public Opinion Project, which surveys public opinion and governance perceptions within the region. Next, the Global Violent Deaths Database, which measures killings and legal interventions, which I use for police violence. I used the VDEM dataset, which helped me identify institutional factors. And then I also reviewed academic literature centering the analysis between 2004 and 2023, and including several countries like the ones listed here. So for my results, I looked at trust across years and countries. So let's look at these graphs very quickly. So we have mean trust in police by country and mean trust in police by year. On the y-axis, we have the mean trust going from 0, no trust, to 1, a lot of trust, and the same on this graph. And then on the x-axis here, we just have a couple countries that I included in my analysis, along with the year range that I included. And so across the data, I saw that trust in law enforcement varies, not just between countries, but over time. So we could see that a country like Chile, which has gone through a lot of democratization recently, has improved perceptions a bit and has higher mean trust in police. And then we can contrast this all the way down to Venezuela, which has a very, very low mean trust in police. And then we just generally see that varying pattern across the years as well. So we see that 2009 had a higher mean trust in police as compared to 2008. And then that pattern can be seen across 2017 and 2018. So, socioeconomic status and social class. We're looking at our first hypothesis that lower income levels and lower social class would lead to lower trust in law enforcement. So, for these two graphs, again, let's look at the graphs. The mean trust on the y-axis goes from 0 to 0.7 on both graphs. And then for this graph, we look at income levels, sufficiency to support self and family, and then ability to save. And then for this graph, just the various social classes. And I did find support for this hypothesis, so let's get into the data. People from lower income or marginalized backgrounds, including respondents here and here, consistently reported less trust in law enforcement. And this makes sense, right? They're more likely to face discrimination, extortion, or neglect from police. And then in contrast, wealthier, just respondents from wealthier communities, including those here, and also over here, often experienced more responsive or less aggressive policing. So my data did find support for this hypothesis. Next, authoritarian experience and militarized police. So the hypothesis says that evidence of authoritarian experience and presence of military policing should correlate with lower trust in law enforcement. So again, let's look at the graph. So here on the y-axis, we go from 0 to 1 on the mean trust in police. And then we look at democratic breakdowns just to represent countries that have had military regimes, just authoritarian experiences. So in order for the data to be consistent with his hypothesis, we should see a general trend going this way, right? And my data was consistent with the hypothesis. So we saw that countries that lived under authoritarian or militarized regimes, like Brazil or Chile, which would show up here with more democratic breakdowns, still showed lower levels of trust today. The old policing systems were rarely restructured after dictatorship periods, which means that citizens continued associating the police with repression rather than protection. So we generally see that this data finds support for this hypothesis, but we did have a couple outliers here, including Suriname, Uruguay, and Ecuador. But generally, we do see that trend showing support for the hypothesis. And then lastly, perceived police misconduct. The graph here goes from 0.3 to 0.7 only to allow us to see a better view of the regression line. On the x-axis, there are violent deaths per 100,000 citizens, and that data is coming from killings in legal interventions. That's a proxy used for police violence. And then, so the hypothesis shows that countries with higher publicly perceived police violence should correlate with lower mean trust in police. And we're expecting a negative slope to show support for that hypothesis. And that's exactly what we found. So we did find that there was a strong link between state violence and police distrust. Countries with higher reported or perceived police killings, such as Jamaica or Venezuela in this area. I should say that each one of these circles is a country. So we have Jamaica and Venezuela over here. They tended to have significantly lower levels of trust overall across respondents, as opposed to Costa Rica, Canada, along with Suriname in this different region. So we generally saw that violence erodes that idea that the police are there to serve the community. So I did find support for that last hypothesis. So to conclude, all three hypotheses were supported. Inequality shapes perception, militarization affects lasting confidence, and violence erodes trust. The general takeaway is that police trust varies widely across this region, and it's deeply rooted in history and lived experience. Strengthening democratic governance means addressing these roots and not just enforcing laws more strictly. So this research contributes to understanding democratic governance and police accountability across the region, but it also opens up several new questions. How do specific police reforms affect trust over time? How does media shape perceptions of policing? And then also, how does this region compare to others facing similar challenges, like parts of Africa or even parts of Eastern Europe? The hope is to help inform reform strategies that actually build trust, rebuilding that trust rather than just tightening control in those communities. Thank you.
Awesome. Thank you so much for sharing. And we're going to open the floor for questions for Kaylor.
Hi, Kaylor. I've got a question for you. You mentioned your hypothesis was that trust in police or the police themselves are critical to the success of a democratic governance. What is it about police or policing that makes that such kind of a pillar for, in terms of your hypothesis? And are there any other things that contribute to the success of democracy?
Yes, definitely. Thank you so much for your question. So, yeah, I looked at that trust in police being important for democracy. We decided that, it's extremely important for the citizens to have trust in the forces that are meant to protect them, the forces within the community that are supposed to be upholding those standards and norms. And it's just extremely important. For not just the police to, not be corrupt, but generally for the institutions to be there to protect the people and the institutions to be there to uphold those standards that are important for the people. So not just police, but also looking at, the socialization institutions, including, the schools and also the government, and judicial forces as well. Those are extremely important in upholding the democracy.
Thank you.
Awesome. Thank you so much. And so we are going to move on to our next presenter, Quentin Adkins. If you want to go ahead and share your screen. And Kaylor, you did have another question in the chat if you want to answer that there. Or we can always come back to it at the end of the event. So Quentin, I'll let you take it away.
Hello. Hi, everybody. My name is Quentin. I'm a nursing student at FSU right now, and my project was on care seeking related to HIV during COVID-19 pandemic in Tallahassee, ultimately showing the intersection between the two health crises of COVID and HIV and reflecting the broader concept of how acute health crises can affect pre-existing and chronic diseases. So So a little bit of background and significance. As we all know and experience, COVID-19 disrupted healthcare systems globally. HIV prevention, testing, and treatment were heavily affected. There's very limited research on smaller US communities, and Tallahassee is one of them. And so it's important that we recognize and understand the disruptions and disparities. Therefore, we can better future public health initiatives during a crisis. And so the objectives of my research were to analyze care-seeking behaviors, including HIV testing, diagnosis rates, and changes in PrEP use, compare trends at the Tallahassee and the local level to a broader level, collect qualitative insight from clinicians, organizations, public health leaders to provide a little bit of context to the quantitative data that we see, and then identify the barriers, obstacles, and lessons that we learned so we can better ourselves in a future public health crisis. And then those are the questions. And so a little bit of literature. So the literature shows that globally, HIV testing did decrease in 2020. Specifically, this study that showed 28 countries showed that it decreased by 22%, and that PrEP initiations were down 36%. Nationally, at the US level, HIV testing did decrease by 42.6%, which is almost half in 2020, and PrEP prescriptions decreased by about 6%. And so in Florida, there was not a lot of actual literature research yet. COVID wasn't that long ago, it was only 5 years ago, so that does make sense. And also just like barriers include so stigma, cost, and accessibility, but other states did have this research done and had similar findings, so we can assume that Florida did the same. And then also ultimately all of them showed that the MSM, transgender individuals, youth, and Black and Hispanic communities were all the most impacted by these changes. And so I took a mixed methods approach to this project. I pulled a lot of data from quantitative sources, and then to provide context to this, I interviewed with the community to get some qualitative data on this. And so starting with quantitative, um, all of the graphs kind of show this little pandemic dip right here. I don't know if you guys can see my mouse, but according to the CDC surveillance reports, there was a 17% drop here in the US, and the most impacted demographic was Black African American MSM and youth. And then similarly in Florida, Florida charts showed the same thing with AIDS diagnoses kind of reflecting the same thing. There was a dip here with a rebound right there. And then I have the numbers for you guys. And then at the Leon County level, Leon County had the same dip with a very, very, very sharp rebound. And so ultimately 52.5% from 2019 to 2023, which is way more than half, new HIV diagnoses. And specifically, 68.9% of them were Black residents, 88.9% of them were male, and 38% were from the ages of 13 to 24. And MSM conducted for way more than half, for a little over half of the transmissions. And so this part right here, the rebounds. So what does that mean? So that's why I wanted to do the qualitative portion to kind of interview people in the community to get more context on that. And so routine testing and outreach were, so what I found after interviewing some people were routine testing and outreach were suspended. In fact, a lot of places actually closed down that historically did HIV testing to convert to COVID testing centers. Staffing shortages, personal protective equipment scarcity, misinformation were all leading barriers and messing up this care. And then the fear of contracting COVID-19 reduced clinic visits and testing. If you have HIV, you're immunosuppressed, and so these patients may not want to go out into the community. They have an increased fear. And so for workers, the work environment was not ideal. There was a lot of things changing all the time. Certain populations were a lot harder to reach. Telehealth was very valuable. It was a very valuable resource, but limited to technical barriers for older and lower income patients. If you don't have access to it, it's not going to help you. And then drive up and car site HIV, STI testing, incentivize outreach efforts, mail order prescription, self-testing kits. These were all things that doctors' offices and healthcare workers try to implement to adapt to the change. And that could be a reason as to why going back into the rebound being really sharp for Leon County was that we had more coverage because they did more incentivized research. So, for example, an executive director at local community health organization said that they actually went into the communities and they gave out food and they gave out drinks and they gave out things that the people need. So they were trying to meet the people where they were at. And so ultimately, COVID caused major disruptions to care seeking in relation to HIV. We tried to adapt with resilience, telehealth, car-side testing, putting in these incentives. Leon County mirrored the national state pandemic dip and had a steep decline and a really, really sharp rebound. Routine testing, outreach events, and in-person appointments were all suspended from the lockdowns, the staffing shortages, and a fear of exposure. And then disparities worsened. Minorities faced larger barriers. Telehealth and self-testing options were to maintain some continuity, but were limited by these barriers for older and low-income patients. Organizationally, there were struggles with rapid changing, misinformation, like telehealth rollout was frustrating. There was inconsistent access for everyone. And so there was also personal strain. Family members have children, remote work. It's just all systemic stress. And so what can we take away from this? So what happened in Tallahassee experiences that community-driven adaptations can actually sustain and improve care during this crisis. Targeted outreach is really going to make a change for the young Black MSM, the homeless, marginalized individuals. We need to ultimately maintain outreach to marginalized groups and strengthen public health infrastructure to minimize inequities during a future emergency. And so ultimately, in the future, it is important that we take the experiences that we learn from a health crisis to better a future approach, and it's essential to keep into consideration pre-existing chronic diseases such as HIV when addressing a new health crisis like COVID, and that we take a more inclusive approach that's community-driven, as historically disadvantaged populations are consistently the most affected by chronic diseases. So we need to make sure that they're the ones getting access to care that they need. And so, yeah, a special thank you to my team and all these other people that helped me out. And there's my references. And I have a few minutes for questions. If anybody has any questions.
Awesome. Great job, Quentin. Yeah, as you said, we're opening the floor for questions. So if you want to drop those in the chat or just ask them directly. Liz says, this is an incredible, important project. Thank you for doing this work.
Thank you.
Hey, Quentin. And when you're talking about your conclusions and talking about the lessons from what everyone experienced during the pandemic, they used the phrase that like this is what we should be doing, right?
Yes.
From your conversations with the practitioners, what have you seen as being like permanent changes where they may be doing things differently than they did pre-pandemic?
I think that like pre-pandemically, um, I think that pre-pandemically, they're kind of addressing a lot more of this misinformation. A lot more of the community is way more educated about diseases and health crises and stuff now. And so, and I think that pre-pandemic, it was a lot of people coming to the healthcare provider, but like I said, the incentivized actual outreach efforts did help in some capacity, maybe help. And so post-pandemic, um, more of these people like I think that now we are more looking at the actual communities affected and how to help these people. And so, yeah.
Awesome. So that is great. Quentin, thank you so much for sharing that information. We have one more. Were you able to partner with Big Bend Cares at all?
Yes, I was. They were I don't know if I they were they were one of the interviewers that I did. I got a lot of the directors and stuff from them, and they do a lot of HIV work with the community. So
Great. Thank you so much. So now we are going to jump over to our next presenter, Maya Gold. So Maya, whenever you're ready, feel free to share your screen. And thank you so much, Quentin.
Let me. Okay. Sorry, give me just a second. Okay, can everyone see this?
It's just a black screen.
Oh, no. Let me see. Can you see my screen now?
Yes.
Okay, so if I go into, can you see now?
No.
Oh, it's really weird. So if I go into a slideshow, then it doesn't let me. Wait a second. Sorry about that. Okay. Is it okay if I just present this way?
Yeah, we can see that.
Okay, perfect. So good morning, everyone. My name is Maya Gold, and I'm going to be presenting my research on ferromagnetism and magnetic phase boundaries in the yttrium, iron 6, cobalt 6, germanium 6 systems. So a little introduction on my research. Magnets are at the heart of nearly every piece of modern technology, from smartphones to computers to electric vehicles and medical imaging. However, even though magnets are everywhere, we still don't fully understand how to design materials that exhibit specific magnetic behaviors efficiently and affordably. Our group studies materials that exhibit what's called itinerant magnetism, where the same electrons responsible for electrical conduction are also responsible for magnetic behavior. These systems are fascinating because their magnetic properties are extremely sensitive to chemical composition and structure, making them promising candidates for the next generation magnetic memory and spintronic devices. In this talk, I'm going to walk through how we studied a family of compounds known as the iron or the yttrium iron 6, cobalt 6, germanium 6, and what we discovered about their magnetic transitions and why that matters for material designs. So why magnets matter? Let's begin by considering why we study new magnetic materials in the first place. Magnets play an essential role in modern technology. They're used in electronics to store and process data, in energy systems like wind turbines and electric motors, and in medicine through MRI and other imaging tools. However, as technology becomes faster, and more energy efficient, our current magnetic materials are reaching their limits. Traditional magnetic memory depends on layered, complex structures that are expensive and difficult to scale. The long-term vision of this research field is to develop magnetic memory that can store information directly within the magnetic moments of atoms instead of relying solely on electric charge. This type of memory would be faster, more durable, and more energy efficient. The transition metals we study are ideal candidates for this because we can combine them with strong magnetism and metallic conductivity. In other words, they could form on the basis of the next generation of high-performance magnetic materials. So our specific research goal was to understand how substituting cobalt for iron affects the magnetism in the compound yttrium iron 6 germanium 6, leading to the family of materials known as yttrium iron 6 cobalt 6 germanium 6. In this system, the two endpoints, yttrium iron 6 germanium 6 and yttrium cobalt 6 germanium 6, represent very different behaviors. Yttrium iron 6 germanium 6 is antiferromagnetic, which means that its atomic magnetism moments align in opposite directions and cancel each other out. So the material as a whole isn't magnetic. Yttrium cobalt 6 germanium 6, on the other hand, is paramagnetic, meaning it doesn't show any long-range magnetic order at normal temperature. By carefully substituting cobalt for iron in varying amounts, we can watch how the material transitions from one magnetic state to another. Our overarching goal is to map the magnetic phase boundary, the precise region where the compound's magnetic behavior switches between antiferromagnetism and ferromagnetism, to understand what structural and electronic changes drive that transition. On this slide, you can see a representation of the phase change and the series of compositions and how they're influenced by temperature. Let's discuss how these materials were made and characterized. The yttrium iron 6 cobalt 6 germanium 6 were synthesized using arc melting, where pure elements yttrium, iron, cobalt, and germanium were melted together in an inert argon atmosphere. After the melt solidified, the samples were annealed at around 900 degrees Celsius for several days to ensure that all the elements distribute evenly. Once they were cooled, the materials are finally ground and examined through X-ray diffraction, or XRD, to verify their crystal structures. Most compositions form the expected layer hexagonal or orthorhombic structures, typically from this compound family. Occasionally, we observe small traces of yttrium oxide impurities, which were removed by gentle acid treatment to obtain pure samples. Finally, we measured magnetic properties using magnetometry, which records how the magnetization changes within temperature. This allows us to identify the point where each sample transitioned from non-magnetic to magnetic behavior. If you look at the image on the slide, you can see the experimental setup used for arc melting and XRD pattern confirming phase purity. So our results revealed an interesting trend. At low cobalt concentrations, the materials behaved as antiferromagnets with neighboring atomic spins oriented in opposite directions, canceling each other out. As we gradually replaced iron with cobalt, the antiferromagnetic ordering weakened. At intermediate compositions, a new magnetic state emerged, ferromagnetism, where the spins aligned in the same direction, producing a net magnetic moment. In practical terms, this means that the materials start to behave like conventional magnets below a certain temperature. For most of our samples, the transition occurred roughly between negative 50 degrees Celsius and negative 100 degrees Celsius, depending on the exact cobalt content. On the phase diagram displayed, you can see how the system evolves. At one end, iron-rich samples show antiferromagnetic order, and at the other, cobalt-rich samples are non-magnetic or paramagnetic, and in between, we observe the onset of ferromagnetism. This continuous transformation illustrates how precisely we can tune magnetic behaviors through the composition. The structural data also revealed clear patterns. Using X-ray diffraction, we observed that the unit cell volume, the physical space that occupied by each repeating structural unit, increased smoothly as we added more cobalt. This behavior follows Vegard's law, which tells us that the lattice parameters of a solid solution change linearly with composition. The linear trend confirms that cobalt successfully replaced iron in the structure, and we achieved uniform without mixing significant phase separation. Electronically, cobalt adds extra electrons to the system, slightly changing the balance of charge carriers and altering the density of electronic states near what's called the Fermi level, the energy region that determines whether a material can support the magnetism or not. These small adjustments can tip the balance between magnetic and non-magnetic behavior. Essentially, adding cobalt increases the likelihood that the electron spins will align, leading to the emergence of ferromagnetism. If you look at the plot on this slide, you'll see the steady increase in volume as cobalt content rises, confirming the smooth structural evolution. This system is an excellent example of itinerant magnetism, a type of magnetism arising from electrons that move freely through the crystal lattice while still carrying magnetic spin. In this context, the Stoner criterion provides a simple theoretical explanation. It states that the magnetism occurs when the product of two factors, the number of available electronic states and the strength of the spin exchange interaction, exceed a certain threshold. In simpler terms, when the density of available electronic states is high enough, the electrons interact strongly with one another, they tend to align their spins spontaneously, producing a magnetic state. As cobalt replaces iron, it modifies the electronic state structure so that the system condition is met, causing the system to transition from antiferromagnetism to ferromagnetism. This concept helps us understand why even small compositional changes can have such profound effects on magnetic behavior. To summarize, our research successfully established a magnetic phase diagram for the yttrium iron 6 cobalt 6 germanium 6 system. We demonstrated a clear and controllable transformation from antiferromagnetic to ferromagnetic behavior as cobalt concentration increased. We also confirmed that this magnetic transition is accompanied by a smooth structural evolution and electronic reconfiguration consistent with the theoretical predictions for itinerant magnetic systems. The results contribute to a deeper understanding of how magnetism can be tuned chemically and highlight the potential of these materials for future applications in magnetic memory and spintronics, where precise control of magnetic states is essential. Moving forward, our group aims to extend the study by exploring related compounds with other rare earth elements and by using neutron diffraction to determine the exact spin arrangements with the magnetic phases. Before I conclude, I'd like to acknowledge Dr. Michael Shatrock for his mentorship and guidance throughout the project, as well as members of the Shatrock group who contributed to the synthesis, characterization, and computational modeling. Thank you all for your attention.
Thank you, Maya. I think we can squeeze one question in for Maya, and then we can move on to our next presenter. I'll give that a few moments. And then next we'll be having Emma Sag present for us. Any questions? Great. Well, thank you so much, Maya. Oh, did I hear somebody?
Yeah, I was just going to ask, like, what's something unexpected that you found through your work?
Sometimes, well, it was very common when creating the samples. Can you hear me? Yeah. There's a lot of factors when creating the samples, such as we work in this thing called the box, and it's very it's like an argon space, and it's compressed, and so sometimes oxygen will get into the box and it completely messes things up. But also we were able to see different types of reactions with those metals throughout the entire experiment with, you know, different chemical interactions. That kind of, I mean, it didn't really answer what we were looking for, but it still was fascinating to see the, you know, the interactions between like oxygen mixing with those chemically sensitive products.
Great. Thank you so much, Maya. Next, we'll have Emma. So Emma, whenever you're ready, feel free to share your screen.
Gotcha. How's that? Everybody see it?
Perfect, yes.
Good morning. My name is Emma Sag, and I'm a senior majoring in behavioral neuroscience, and I've been participating in the Contextual and Automatic Influences on Relationships lab. I've been studying human AI relationships through the lens of my study called Companionship Without Commitment, Exploring the Consequences of Human AI Relationships. We all know that loneliness has become an increasingly pervasive issue in contemporary society, exacerbated by factors such as widespread social media usage and declining mental health. Meanwhile, advances in AI intelligence have introduced new forms of companionship that bypass the complexities inherent in human relationships. As a result, AI companionship has emerged as an appealing alternative for individuals who struggle with traditional social interactions, offering a means to fulfill social and emotional needs. People high in attachment anxiety are especially prone to turning to AI for social connection, as they struggle to manage negative emotions and rely on external sources for comfort, which can become addictive because sadness mediates the relationship between attachment anxiety and addictive behaviors. As relationships are appealing because they provide customizable, non-judgmental companionship designed to prioritize user satisfaction. It's important to note that despite the risk of addiction for vulnerable populations, AI has significant potential in mental health care by offering accessible tools to identify high-risk individuals and prompt early intervention before symptoms worsen. However, the potential for consistent surveillance via an AI companion is also present, as platforms that host these companions have the ability to collect, organize, analyze, and ultimately exploit sensitive personal data divulged in confidence. Altogether, these findings highlight both the promise and the potential pitfalls of AI companionship, underscoring the need to understand how individual differences shape its psychological impact. This study was longitudinal in nature, spanning 21 days, wherein data was collected from undergraduate students participating for class credit. Initially, participants were administered a baseline survey which utilized the UCLA Loneliness Scale, the Adult Attachment Questionnaire, the Rejection Sensitivity Questionnaire, and the SES-D scale to assess loneliness, attachment style, rejection sensitivity, and depression, respectively. They were then provided a friendly AI chatbot and administered daily surveys for the duration of the study over the following 3 weeks, which tracked the daily time spent with close human others, such as friends and significant others, as well as the time spent interacting with the AI chatbot. On day 22, a check-in survey was given, which re-administered all baseline measures to assess change over time. Please note that the data collection is still ongoing. So we tested 2 sets of predictions. The first was that rejection sensitivity and attachment anxiety would predict greater AI usage. Notably, neither correlation reached statistical significance, as both p-values are fairly high. The other was that AI usage would result in reduced loneliness and depression even after controlling for human interaction. These 2 did not reach statistical significance, as AI usage did not predict reduction in loneliness or depression, though significance was approached in the case of depression, which so far has the lowest p-value. These graphs are scatter plots which illustrate the changes in loneliness and depression in association with the participants' time spent with the AI. Please note that while the current results are not significant, the current sample size is small and so far underpowered to detect any effects. While all 80 participants completed the baseline survey, only 55 interacted with the AI after baseline, and even fewer completed the check-in. So notably, the regression used only 26 data points. In the final analysis for this study, longitudinal methods will be used to increase accuracy in detecting the impact of AI interactions rather than the current check-in minus baseline measure. Although the current data showed no short-term effects on loneliness or depression, over-reliance on AI could discourage human connection if users substitute real social relationships with AI. Additionally, continuous validation and lack of interpersonal challenge from AI companions could stunt emotional and social growth, particularly among those high in rejection sensitivity. Though most importantly, those who find safety and acceptance in AI may become less likely to seek social and emotional support. While this current study remains somewhat incomplete, there are many future directions to take to broaden our understanding of how AI and psychology interact. For example, one could examine how Generation Alpha raised alongside AI differs from older generations in sociability, attachment, and perception of AI. Additionally, longitudinal studies can be used to assess the long-term life satisfaction and relational patterns of individuals who choose to form AI partnerships, and whether these people also tend to have an anxious or avoidant attachment style. As previously mentioned, AI can also be used in clinical settings as a stepping stone to that end could be to explore whether AI systems trained with distinct empathy or language models better meet unique psychological needs. For example, it could be used by clinicians in controlled rejection therapy, wherein a patient connects with an AI, which, under the guidance of the therapist, exposes the patient to appropriate levels of rejection. I'd like to give special thanks to the Care Lab for spearheading this research. Thank you. Any questions?
Thank you, Emma. Yeah, any questions for Emma? Very interesting topic for sure.
Hi, Emma. Great job. Thank you for sharing. In your future studies, you said you kind of want to expand this to account for generational differences, but would there be any other population factors or demographic factors that could be included in future studies?
Yeah, I would love to see how older generations also interact with AI. I think that could be very interesting, especially since older populations tend to be more isolated just naturally. I feel like that could be a great future avenue.
Thank you.
Great. Any other questions for Emma? No. Awesome. Well, if you do have any questions, feel free to drop them in the chat. But we are going to move on to our next presenter, Rudy. So Rudy, whenever you're ready, feel free to share your screen. And Emma, thank you again for sharing your research with us.
Hello, everyone. As mentioned before, my name is Rudy. I currently work at the Writers Center as a research assistant, and I'm majoring in civil engineering. And today I'll be presenting you my research specifically on the advancement of multi-scale analytical techniques for REOB detection and characterization in asphalt binders. So starting off, what are asphalt binders? So asphalt binders are the viscoelastic petroleum-based materials that act as the glue in the pavement. So they help all the aggregate or the rocks stick together to create the structure that basically is keeping your car from collapsing into the ground. And it's also important to note that its mechanical behavior is dependent on mainly two factors, temperature and the loading frequency. So a good way to imagine asphalt that is helpful is kind of like a Rice Krispie. So for a Rice Krispie, you have like the sticky marshmallow, and then you also have like the actual like cereal Rice Krispie that's being held together by the marshmallow. So asphalt binders are the marshmallow that's holding everything together. And in addition, it's also important to note, what is REOB? So REOB is a byproduct of the recycling process of lubricant oil. It's not the recycled lubricant oil itself, it's something that comes from the process that we're trying to dispose of. And in the past, REOB has been used as a, in the past, REOB has been used as a fluxing.
Sorry, Rudy, 1 second. Are you able to unmute?
Yes.
Okay, awesome. Go ahead and continue.
Gotcha. Can you still see my screen?
Yes.
Perfect. Anyways, but yeah, so REOB isn't the lubricant oil being recycled. It's something that's coming from that process that we're trying to dispose of. And in the past, it's been used as a softening agent in asphalt. And in addition, it's important to note its composition depends on the feedstock of the lubricant oils that are being recycled. So what this means is that REOB's composition is extremely unpredictable because there's all kinds of lubricant oils and they all get mixed together and are refined together. So each time a batch is made, that REOB is unique. Here, it gives you kind of an idea of all like the different kinds of lubricant oil. And you could see just for engine oils, you know, everybody's been to a Walmart. If you walk through the the car oil section for that, there's all different kinds. So there's a lot of variability. Here you could see an image of REOB. So here's me sampling it from a pail. And then here you can see Asphalt. So they're both petroleum-based, so they look similar. And they're both black and reflective. But, you know, all this talk about REOB, all this talk about Asphalt, why do we care? Why is this important? Well, in 2007, a large number of new pavements cracked within only 2 to 3 years, way below their expected service life. And after an investigation occurred, it was found that up to 20% of REOB content was found in these binders, in the binders in these pavements. So that sparked an alarm within the Asphalt community. And as a result, they're interested mainly in 3 questions. What are the potential adverse effects of REOB? How does one know if an Asphalt binder contains REOB? And how can one determine how much REOB is used in an Asphalt binder? So is the REOB there in the binder, and how much of it? And what is it going to do to it? So for my research questions, I'm focused on, can TGA be used as a method of quantification and detection of REOB in Asphalt? In addition, I also want to answer the question of, how does REOB affect the thermal stability, aging properties, and performance of Asphalt? So for my materials, I have 3 binder types, and the crude oil sources are all coming from different areas. And as a result, because they're coming from different areas, they have unique chemical compositions. However, for this study, we're only focusing on one AAF, and that's it, just to narrow things down. So here you could see my sample preparation. I get the Asphalt binders, and I'm mixing REOB at different concentrations, 0%, 2%, 5%, 8%, 12%. I'm then blending them in a high shear mixer. That way everything gets spread out and dispersed evenly in a heating mantle to control the temperature. And then from there, we're also aging the samples in an oven. However, for this study, we will only be focusing on the unaged samples that are coming after being mixed together. So here, this gives you kind of an idea of like the scale and scope of the full project itself. There's a lot of different testing methods we want to apply, and we have a lot of samples. However, for this discussion, we will only be focusing again on AAF, unaged, and specifically TGA, DSR, and AFM. So what is TGA? Well, TGA stands for thermogravimetric analysis. Here you can see an image of the device. And what it does is it measures the change in weight of the material as a function of temperature. So you're essentially getting the sample and putting it in an oven, and you're heating up that oven incrementally, and you're seeing how that weight is changing as the temperature increases. And from that, you can also get the derivative to get the rate of weight loss as well. And in addition, you can have different kinds of environment in this oven. So you can have just nitrogen inside it, or you could have air. So here, this is kind of what a sample looks like. This is the pan. So that pan would be attached to a hook that's measuring the weight, and then it would go inside the heating chamber to be degraded. And in addition, we also found that at the end of these tests, it leaves metal particles. And these metal particles are actually coming from the car engines that the REOB was originally inside of, because it's lubricant oil. So it's coming from the friction of the pistons themselves. So you're finding metals like copper and aluminum, and also polymers, which is very interesting. But this is our first chart for TGA. So this chart is of a nitrogen environment. So as you can see, they're very, very similar. And this is because in a nitrogen environment, only one type of reaction is occurring, thermal decomposition, and that's it. Because nitrogen is inert, it can't react with anything in the air, the sample itself. So all it's doing is it's just degrading. And you could see that they have a very, very similar thermal decomposition pattern, even when you add different levels of REOB to the samples. However, if you perform this test in air, you do see more unique behaviors. Specifically, if you look at between these temperature ranges of 250 degrees and 350 degrees, there is a decrease in the thermal stability of the binder. You also see this exhibited in 450 degrees and 550 degrees. Again, you see that decrease in thermal stability. And this thermal stability can be correlated to REOB content as well. So what this means is that REOB, samples that have been modified with REOB are more reactive in an oxidative environment. And this alludes to REOB's capability to induce premature aging, as was shown in the Ontario study. It reacts to air more easily, essentially. You could say that, and that's basically what aging is. Aging is just another way of saying oxidation in our case. And this also shows the potential for REOB quantification, because we're seeing that these changes are occurring incrementally. And what's also important is dynamic shear rheometry, or the DSR. So the DSR is actually measuring the viscoelastic behavior of the sample. So we're actually seeing how it's performing. And it's measuring at different loadings, so different shear loadings, and then at different temperatures. Because as we mentioned, those are kind of the two factors that really influence the mechanical behavior of asphalt. And this is also simulating different traffic and temperature conditions, essentially. Here you could see that, the illustration, and there you can see a test being done side by side. And from that, we saw a reduction in the stiffness of the binder when REOB was added. So the binder was becoming less resistant to deformation from all loading levels. So it didn't matter the frequency the load was being applied, the sample modified with REOB was performing much worse, which makes it more likely to be at risk of rutting, which is, as you can see here, not good for the roads and could lead to traffic accidents. And we would consider this to be a pavement failure. We do not want this to happen. And then lastly, just to touch on very fast, we have atomic force microscopy. So atomic force microscopy captures the nanoscale topography and the phase contrast of these samples at the nanoscale. So the topography is just X, Y, the different heights. And the phase image, though, highlights the differences in the material stiffness and the viscoelastic response. And here you could see an image of the binder sample without REOB. We tend to see these bee-like structures, but we're still trying to figure out what all this means. I'm just throwing in these images because it looks very interesting. Another important thing to note is that we see that within samples that have been modified with REOB, these little white dots are appearing, especially when you compare it to samples that have not been modified with REOB. You don't see that same pattern. So we're still trying to figure out essentially what these white dots are, because we know they're coming from the REOB being introduced to the asphalt binders, but we don't know exactly what they are. But they also could potentially be a method of being able to know when REOB has been added to asphalt. So for my conclusions, TGA was able to illustrate that REOB does lower the thermal stability of asphalt, and it can accelerate the oxidation of the material and lead to faster aging. And likewise, TGA may also have potential for quantification of REOB, specifically in an air environment. As we saw with the nitrogen environment, they exhibit very, very similar thermal degradation behaviors. And lastly, from the DSR, we were able to see that how REOB causes a reduction in the stiffness, putting the asphalt more at risk of rutting. So for future work, we're hoping to get these different testing methods, specifically TGA, FTIR, and AFM, and tie them all to the actual performance of the binder itself. We want to see how these chemical changes within the material can be correlated to its actual performance. But anyways, that concludes my presentation. A huge thank you to my mentor, Dr. Michael Elwardani, and the Writer Center. Thank you.
Awesome. Great job, Rudy. So if anybody has any questions for Rudy, we can take those now.
I've got
Rudy.
Go ahead, Liz.
No, go ahead, Dave. I've already asked the question once. Go ahead.
Oh no, sort of off kilter a little bit, but more just using the knowledge. My question basically is trying to get you to use the knowledge that you gained through this experiment, because the state of Florida is considering banning asphalt shingles on roofs. I was thinking, with the knowledge you gain of REOB and its potential use and things like that, how might some of this affect like that asphalt's use on roofs and stuff like that?
That's a very good question. So what you could do is you can actually kind of simulate I guess you could say, elements that the asphalt is going to experience like on a roof. So you can kind of see like whether or not like it would perform well by actually using the DSR. So you could see at these different temperatures, dealing with these different loads, how is this material going to perform? And from that, like you're able to make like just regulatory decisions like that of, hey, like we see from the lab that long term, this is how the material is going to perform, like in this specific environment, and therefore we don't recommend using it. But a lot of decisions are made from Asphalt labs doing studies like this.
Cool. Thank you.
Any other questions?
I've got one. So you mentioned that REOB is a byproduct. Am I correct?
Yes.
Okay. Is it something that why is it something that we're seeing more of now? Is it something to do with how asphalt is being prepared and used now? Is it something in manufacturing? What is it that's bringing about this current influx of problems with the roads?
That is a fantastic question. So the issue with REOB is it's a product of that recycling, but it's something that we're trying to dispose of. It's the non-distillable components of the lubricant oils that are being recycled, and it's expensive to dispose of it properly. So what'll happen is that asphalt manufacturers have this very strong incentive of adding it to their binders because they'll actually get paid, hey, can you dispose of this by putting it in your binders? So there's a very, very bad negative incentive that causes it to be overused. Because again, in the past, it used to be used at lower levels, but now it's getting higher and higher, and that has to do with these negative economic incentives that exist. Because again, REOB is something that we're trying to dispose of. It is something that we are trying to throw away from this process, or at least find some kind of use for it.
Awesome. Thank you so much.
No, yeah, great question. Anyone else?
I'm not seeing any more questions, but again, Rudy, good job.
Yeah, thank you,
Thank you
everyone.
for presenting your research with us. Next, we have Aleksandra. So Aleksandra, whenever you're ready, go ahead and share your screen.
Alrighty, can everyone see that?
Yes.
Nice. Okay. So, hello everyone. My name is Aleksandra Grechanik, and I'm a behavioral neuroscience major completing my honors in the major thesis. I'm researching how music impacts our cognition, specifically what effect it has on human recognition memory, which is the ability to recognize something you've seen before. So, I'm sure many of you guys have probably heard of the term that music makes us smarter. So, although this is a very broad type of statement that's categorized technically as a myth, it's actually rooted in scientific inquiry. In the world of neuroscience, this phenomenon was referred to as the Mozart effect and was proposed in the early 1990s. It's still a very relevant topic in psychology today, but there's a long-standing debate that's highly inconsistent because some researchers find that music improves our memory while others showcase that it actually has a negative impact. So, to explain these sorts of mixed results, psychologists propose something called the arousal and mood hypothesis. Although this theory is more broad and not exactly specific to music in itself, it can be used to propose a different sort of mechanism for music processing in the brain. So, through this theory, it can be applied that music doesn't directly enhance memory, but rather changes our emotional and physiological state, which in turn affects our cognitive performance. So the problem with this is that this is still a fairly new topic in psychology today. We still don't fully understand how music-evoked emotion influences recognition memory specifically, and only a few studies have actually explored this question in depth. So, essentially, my projects brings back two key frameworks. The first is the arousal and mood hypothesis I just briefly talked about, and the second is something called the dual process model of recognition memory. So this model separates recognition into two different types of components. So the first component is called familiarity. Familiarity is a quick automatic sense that you've seen something. So I kind of like explaining it as the gut feeling. Recollection, on the other hand, is a slower process that involves retrieving key details such as when or where you saw something. These two processes can be seen and measured through EEG signals and actually occur in different areas of the human brain. So both familiarity and recollection have their own distinct regions in the brain, and we're able to see them through something called event-related potentials, or ERPs. So for familiarity, the ERP component is called the FN400 and appears in the frontal region of the brain. So in the little diagram, it's the purple coded region. For recollection, the ERP component is called the P600 and can be seen in the parietal or the yellow region on top. By looking at both of these theoretical frameworks, my project explores how music shapes memory at not only the behavioral, but also the neural levels. So the main question guiding my research is, in what ways does music-evoked emotion influence recognition memory? It's hypothesized that positive mood and higher levels of arousal will lead to better recognition memory. At the neural level, I predict that better recognition will show larger P600 amplitudes, which are linked to recollection, while weaker recognition will show larger FN400 amplitudes, which are linked to familiarity. Essentially, I expect to see that emotionally engaging music helps us remember things better. And in order to test this hypothesis, I'm using a between subjects design with 5 groups. So these are the groups that I listed on the slide, but in addition to those, I also have one silent control group to act as a baseline. So all my participants are FSU undergraduate students between 18 and 30 with less than 1 year of formal music instruction. I made this as a sort of exclusion criteria because it's been shown that people that have played an instrument or participated in things like choir or band actually process music differently in their brains. So I wanted to limit any confounding variables. So just a quick run through of the procedure. My participants come in and I have them listen to 10 minutes of instrumental music designed to evoke a specific combination of mood and arousal. For instance, if the participant is in the high arousal positive condition, which is that first one over there, they listen to a more upbeat and happy piece of music, while low arousal negative conditions are exposed to more dissonant and subjectively unpleasing music. So each song was pre-selected and highlighted by me. And in the case of the silent control group, they just kind of sit there for 10 minutes in silence to serve as their baseline. After the music exposure, participants complete a short survey evaluating their mood and arousal levels and are exposed to 40 black and white pictures. So this acts as their encoding task. After their encoding, I place an EEG cap on their head, which roughly takes me about half an hour to do so. And this acts as a distraction task to kind of distract them from the pictures they've just seen. Afterwards, they're tested on, this time, 80 new black and white pictures. So 40 of those are the pictures that they saw previously, and the 40 other ones are brand new pictures that they've never seen before. And their job is kind of to distinguish whether this is a picture that they've seen or if this is a new picture that they've never seen before. So while participants do the recognition task, they wear the 64-channel EEG cap that I just placed on them, which records the brain's electrical activity. This allows me to measure not only the behavioral measures of their performance, such as accuracy and timing of the task, but also the ERP components I briefly talked about earlier. So together, these measures reveal both how well and how deeply participants can remember what they've seen. In terms of significance, this research matters because it helps us understand the emotional foundations of memory and how the music we listen to can literally shape how we remember things. At the end of the study, if I end up having significant results, these findings could help design non-invasive music-based interventions for people with age-related cognitive decline. So some examples of this include Alzheimer's, Parkinson's, and just like different sorts of dementia. And so far, I've been seeing pretty significant results. So as long as this trend continues, then we are good to go. These findings can also be applied in music therapy practices and contribute to the overall understanding of the interplay between music, emotion, and cognition. So, what is next? I started drafting this thesis last semester and just got IRB approval to start running my participants in September. So I've only been running them for a couple of months, but I hope to finish collecting all of my data and running all of my participants by the end of this semester to later present my or defend my thesis in the spring of 2026. I have a board of amazing professors who I definitely could not have done my project without, which includes Dr. Chris Martin from the psychology department, as well as Ashley Piper, and from the music therapy department, Dr. Lori Gooding. So I'm very appreciative of all of their help, and now I just kind of want to open the floor to you guys and answer any questions you might have.
Thanks, Aleksandra. Any questions from our audience?
Yeah, Aleksandra, you mentioned in the study, kind of when you were introducing it to us, that your participants were right-handed. Why was that important to note, or was that a requirement to be in the study?
So that's actually a requirement for all EEG studies. So the way the EEG works is that they can only focus on one half of the brain at a time. So because the majority of people are right-handed, my lab uses a right-handed EEG cap. There are like other caps that are specifically designed for left-handed people, but those just aren't used commonly.
Oh, okay. I didn't know that. Thank you. That's so interesting.
Yeah. Any other questions?
There's one in the chat. Let me see here. Do you believe specific musical genres, classical, jazz, pop, etc., can have a more beneficial impact than others based on your results?
So that's actually part of my research question. So my conditions are, they kind of involve different types of music. So for example, the high arousal positive condition is more upbeat, so it's more pop or rock music. Then I have my high arousal negative condition, which is more metal music because that's still arousing but can be subjectively perceived to be more negative. So yes, I do think that different types of music have different effects, but we will know for sure at the end of my study. And then I see there's one more question that's, how do you think your research might affect the field of music therapy? I feel like, so I'm only studying memory specifically, but if these findings are proven consistent, then they can be used to see if it also affects other components of cognitive performance. So not only memory, it could also be linked to, spatial awareness. So like where you are. For me, memory could be linked to PTSD. So for people that struggle with PTSD and go to music therapy to kind of calm themselves down, if it's proven that lower arousing and more positive music can calm them down, then that type of music can be used in their music therapy.
Great. Thank you so much. And next, thank you for sharing. Great. And now we have our next presenter, Samuel. Samuel, whenever you're ready, go ahead and share. Thank you again, Aleksandra, for sharing your research with us.
Great.
Right. Hello, everyone. My name is Samuel Salib, and today I'll be sharing my Global Scholars capstone project. My work focuses on something that we often overlook in healthcare, which is the emotional impact that hospital volunteers have on patients. Over the summer at Tallahassee Memorial Hospital, I spent a lot of time walking with patients, talking with them, and just being present. And I started noticing that these simple interactions really seem to change people, their mood and their comfort, as well as their motivation. So this project is really about understanding that human side of recovery. So just a little bit before we go into the findings, I want to acknowledge my positionality. I am a pre-med student in mobility team volunteer, so I spend a lot of my perspective time from seeing patients and being with them. And I often interact with like through very personal moments and everyday moments and helping them just walk, feel safe again, getting out of bed, or just talking when they feel alone. I also come from a neuroscience research background, so naturally, I think about recovery through the brain-body connection. I'm also very aware um, uh, that I'm still like early in my clinical experience because of that, I use reflective journaling and feedback from staff and other volunteers to keep myself grounded to make sure I wasn't misreading patient emotions or injecting my own bias. And my focus felt like was to truly capture how the patients felt. So when I started looking at the literature, I noticed something interesting, and that there's a lot of research showing that patient-centered care improves comfort, trust, emotional well-being, and volunteers are mentioned as part of a larger care system, but their impact is rarely isolated. So volunteers have a unique role in that they're not just rushed. They're not charting. They don't have that 5 tasks waiting for them in the hallway. They have the freedom to sit down with someone, talk, and walk at the patient's pace. But because this role is so flexible and non-clinical, research often overlooks it in the process of healing and healthcare. So my project focuses specifically on what volunteers would uniquely bring to a patient's emotional landscape. So with that gap in mind, I centered the project on 3 questions. First, how do volunteers influence patient comfort and emotional well-being? Second, what emotional, social needs do volunteers end up meeting, especially when staff don't have the time? And finally, how do patients themselves describe these interactions and the way volunteers make them feel? These questions helped guide and shape every interview process that I went through at the hospital, and made sure to follow the strict ethical guidelines when conducting these interviews. So with that gap in mind, to explore these questions, I used a qualitative approach. Over the summer, I had semi-structured conversations with 18 different patients across surgical recovery, chronic care, and rehabilitation units. They weren't really strict interviews. They happened naturally during walking sessions or at the bedside, which naturally made patients open up a little bit more. I also observed 7 volunteers while they worked, paying attention to tone of voice, body language, and emotional shifts in the patients. I met with a nurse who also worked closely with volunteers, and her insights helped contextualize what I was seeing. Throughout all of this, I kept a daily reflective journal to document patterns, movements that stood out, and my own assumptions. And a reminder, everything was HIPAA compliant and voluntary and fully anonymous. So of the 18 patients that I spoke with represented like a wide range of situations, some coming from recent surgery, some from long-term illness, and some rehabilitation after injury. The average interaction lasted around 25 to 30 minutes, with some lasting almost an hour. But what struck me was how consistent the emotional patterns were. It didn't matter whether someone was recovering from surgery or dealing with a chronic condition, the presence of volunteers seemed to have similar effects on mood and comfort. So to get a clearer picture, I asked patients to quickly rate how they felt before and after interactions. Here's about what the data showed. 72% said they felt more relaxed afterward. 61% said they felt less lonely. 67% they were more willing to walk. 67% said they were more willing to walk or move after encouragement. And 83% said volunteer interactions made the time pass faster. And these aren't by standard medical measurements, but they do highlight something important. Emotional comfort through volunteers improves noticeably when volunteers provide more patient interaction than what's typically provided by hospital staff. So when I code everything, there were 3 major emotional themes that came up. The first was human connection. Patients said that the volunteers helped them feel valued, seen, and listened to, and many shared personal stories and opened up about their lives in ways they normally wouldn't. The second main theme was emotional stabilization. You could see that many patients had lower levels of anxiety, shoulders relaxed, their breathing slowed down, voice softened, and patients who started off withdrawn would gradually become more talkative or open. And then the third theme was motivation. Volunteers made patients feel more supported, and that support made them more willing to walk, try a little harder, push through discomfort. And it wasn't forceful. It was more like being there with them and reminding them that they're not going through this alone. So there were several quotes I really highlighted the heart of the project, with one patient telling me, talking to you makes the room feel less empty, and another patient saying, you help the day go by faster. A patient I walked with several times said, walking with volunteers helps me feel normal again. The idea of normalcy, feeling like a person instead of a patient, came up a lot. And that's something that volunteers simply provide by spending time and being present. From the staff perspective, nurses and staff both echoed a lot about what patients said. They mentioned that volunteers would help reduce anxiety and improve patient willingness to mobilize and even reduce call button frequency. One nurse said something that stuck with me, that volunteers give the kind of emotional time we wish we had, but we can't always provide. And that really shows how volunteers help fill that emotional gap that the healthcare system doesn't always have bandwidth for. And when I spoke with several other volunteers, they also noticed similar patterns. They said patients often opened up with more volunteers than with staff, simply because the dynamic feels less rushed and more personal. A few volunteers talked about um, seeing the immediate mood shifts, or seeing hesitant patients end up walking farther because they felt supported. Many said they felt like they were contributing in a meaningful way to the patient, and that patient's attitude and overall morale. So when you bring all this together, the picture becomes clear, is that volunteers do help play a significant role in emotional role in patient recovery. They help make the hospital feel more human. They ease loneliness. They reduce anxiety. They increase motivation, and they create a sense of companionship that patients say they deeply value. While these interactions are small, a conversation, a walk, sometimes like a moment of listening, they do really accumulate into the emotional benefits, and emotional being is directly tied to how people heal. There were several ethical considerations in this project. All conversations were voluntary and anonymous, and I followed strict HIPAA guidelines throughout. The project does have limitations. It is short term, the sample size is small, and the findings rely on self-reported emotions. But even with these limitations, the consistency across the patients makes the patterns meaningful. In conclusion, volunteers do matter, not just as an extra hands in the hospital, but as emotional anchors who help patients cope, recover, and feel very human in a very clinical environment. And while many times that the staff and healthcare workers are not able to fully have the time to be able to see each patient individually and be able to provide the time and support due to the numerous amount of patients, overflow, and just the severity of the situation. The project showed me that like recovery just isn't about medicine or procedures. It's also about the presence of empathy and connection. And volunteers help fill that role. That can't always be measured clinically, but patients feel it deeply. And for me personally, this experience reinforced conversation when we talk about healthcare. Thank you so much for listening. This project genuinely shaped the way I think about patient care, and I'm happy to take any questions.
Great, thanks, Samuel. Any questions from our audience?
I had a question.
Yeah, go ahead.
So this was done more in like a med surg setting, I'm assuming.
Yes, so open clinical setting. So there were several units that I visited, including post-op, surgical care, like cardiology, orthopedic. So patients with a variety of conditions and exposure to different settings.
So how do you feel that this would differ if the volunteers were placed? Because I work in the ER and I don't think that they have volunteers there. So like how do you feel that this would change in like more critical care settings if they put volunteers there?
That's a good question. So in more critical care settings, patients tend to be more thoroughly observed, which is something that's not like widely attributed to other units as well due to overflow and then more stability of the patients. I would believe that in an urgent care setting, priority would be the patient's first most like care, but also to be able to constantly monitor their condition, because typically it would depend. I That's a good question. I think it would really depend on like the patient's overall condition. So, but in most other units where the patients were stabilized and where they weren't under constant watch, the volunteers tended to help be able to provide that support, and that they were able to show up for them. Whereas in the ER, typically, nurses are just right around the corner, and there's more staff. There's a higher staff to patient ratio there. So,
Thank you.
Great. And there's one in the chat. Do you think research like this would encourage more folks to volunteer or more just strengthen the resolve of those already volunteering?
I believe research like this would definitely encourage more volunteers, and I think it's a great thing too, because um like being able to provide support, not just for like your fellow human beings, like through a community, but also be able to uh like um sorry, one second. I believe that this research would help also encourage support for others, people willing to consider volunteering, and that it shows that volunteers do help play a huge role, and that being able to show up for somebody, be able to provide comfort and support, and be able to help improve their overall care. So yes, I do believe.
Great, thank you. Thank you, Samuel, for that presentation. And next, our final presenter of the day, Alec McDaniel. Alec, whenever you're ready, please feel free to share your screen.
Can you hear me now?
Yes.
Okay. Today, the presentation I'm giving is on the work I've done creating a systematic review. The title of our review is Lexical Patterns in Connected Speech Across Aphasia Etiologies. And so it's a pretty long title, but we'll break each part of it down. We'll start with an introduction to what aphasia is and a breakdown of that title. And then we'll go over specific aims and the methodology used, as well as some preliminary findings. And then finally, we'll go over the limitations of this research, as well as next steps. So first, we'll start with that introduction to aphasia. So aphasia at its basis is a language disorder, and it results from stroke or dementia. About 1/3 of strokes will result in aphasia, and about 3 to 4 per 100,000 dementia cases will result in aphasia. But this could also be due to an underdiagnosis or misdiagnosis. And so this number is expected to double in the following years in high-income countries and triple in low and middle-income countries. So the two main etiologies of aphasia are post-stroke aphasia and primary progressive aphasia, but both affect the language areas of the brain. And there are more nuanced classifications than just these two, but these are the main ones. So post-stroke aphasia, as the name implies, is caused by stroke or really any kind of sudden brain damage. Whereas primary progressive aphasia is due to any kind of neurodegenerative disorder, such as Alzheimer's or frontotemporal dementia. The primary part of primary progressive aphasia refers to language being the primary impairment, whereas the progressive part refers to the gradual worsening of the symptoms. And then within each of these categories, there are fluent and non-fluent categorizations, subcategorizations. In fluent categorizations, there's maintained speech, and so the speech remains very smooth and well-paced with normal prosody and grammar. However, the words are going to be incorrect and nonsensical and lacking meaning, and this is because the comprehension in fluent aphasia is impaired. The opposite of this is true in Broca's aphasia or any kind of non-fluent aphasia. The speech is slow, effortful, and halting, and there's reduced grammar. However, in these cases, the comprehension is kept. And so Then we move on to what connected speech is. To elicit connected speech, we do what's called an elicitation task, and connected speech itself is natural, continuous flow of spoken language, and this is in contrast to isolated words or phrases. And so examples of connected speech tasks include picture description, storytelling, and conversation. So an example of a picture, a description task is this picnic scene. Scoring is based on a scale of 0 to 10, with 10 points being given for sentences of normal length, complexity, without slowing down, stopping, or articulatory difficulty, and no incorrect speech sounds. As sentences become less lengthy and more complex, and less complex and more slow and more erred, less points are going to be given. And I can play a small portion of this so you get an idea of what connected speech sounds like.
It looks like we're not getting that audio. You want to just
Okay,
make sure you're sharing?
I can also just read it. So
yeah,
I'll start with the boy who's got the same can't remember it, but he's got the thing over there in the air. He's gonna be flying, driving around with him. He's got a little dog with him, which is fun. Behind them looks like his dad or a friend out working in the water. Likes to try to catch fish and things like that. And so anyways, it's just that kind of natural spoken language. So why is this important? Well, connected speech offers a more ecologically valid insight because of that natural aspect to it. And it also allows quantitative metrics, whereas more structured tasks using rating scales can be quite limited and involve researcher bias. And there's already a move towards this kind of standardization and automation methods, and a move towards more studies comparing tasks across populations. However, we have yet to see whether these metrics differentiate the aphasia types. So to answer that, we can look at some of the existing information. Some of the existing reviews include Boschi et al., which shows which speech and linguistic markers are affected in primary progressive aphasia. And then there's Fromm et al., which identifies, which also helps to identify these meaningful measures. And then Cordella et al., which shows the feasibility of these quantitative and automated approaches. However, there's no review so far that has systematically compared lexical variables across subtypes to profile patients beyond just fluent or non-fluent. And so here are the most important lexical variables and the ones that we searched for when we went to look for studies for our review. So each of these has a very technical definition, but all of them share something about a subject's communication ability and their underlying cognition. And so that's what's really important. So lexical density, for example, is used to assess the complexity of speech or writing and the efficiency of information expression. Lexical diversity is used to show a patient's word finding ability or their richness in their vocabulary. And then the same goes for pausing. It'll just tell you more about a patient. And so next we can go into the specific aims of our study and the methodology behind it, and then some preliminary findings. So our two hypothesis-driven aims were: one, we hope to compare these lexical variables in connected speech samples from individuals with post-stroke aphasia and primary progressive aphasia across different elicitation tasks. And then two, we were hoping to identify shared and distinct speech patterns across post-stroke aphasia and primary progressive aphasia. And this all has the goal of supporting a differential diagnosis between the two and improving the validity of their assessment. So we hypothesized that the two subtypes of primary progressive aphasia, the non-fluent variant and semantic variant, will show differences in the lexical level associated with lexical retrieval. And we also hypothesized that patterns in lexical variables will be shown equally well across tasks. And so creating our review, we used a sort of guideline called the Prisma for meta-analyses. And so here's a large chart about what we did. I'm going to go a little more in depth about the important parts. But basically, we started searching databases, and we found 58 studies. We were able to rule out 5 of them immediately because they were not peer-reviewed articles, or they were duplicates of what we had already found. And then we screened just the title and the abstract, and we found, and we excluded some because there was a review article, a different meta-analysis, or it lacked the appropriate disease group, such as including Parkinson's instead of aphasia. And then after that, we had 50 studies, and we screened them through the full text. 8 of them we didn't include because they were not native English speakers. 10 of them focused on non-lexical variables, and 7 lacked any mean linguistic variable values. And so out of that, out of those 58 studies identified, 33 were excluded and 25 were kept. And something worth noting is that only 2 of those 25 included both stroke and neurodegenerative etiologies. And what we found is that the samples differed in a lot of their qualities, and many did not report on a lot of them. And so the findings really have a low generalizability. And so this gives the implication that future research should really flag differences in things like the duration and clinical severity when trying to generalize the results. However, we do have some preliminary tables. You can see that there are some similarities between them, but also some patterns of differences will emerge, such as influent aphasias here. There are reduced scores on noun naming tasks, but they're more variable. And also in fluent aphasia, the verb density did not reach the classification of severe. And then you can see the effect sizes here. So lexical diversity, for example, had the largest effect size. And then finally, I'll highlight this one particular study that had a lot of participants, but it should be shown that even in this study that was able to highlight the difference of lexical diversity in different patient versus control groups, it did not report on specific aphasia types or how metrics differ to standard clinical measures. And so lastly, we'll go over the limitations of this research and the next steps. So the things we can take home are that we know that lexical metrics are consistently impaired in fluent aphasia and most reproducible across manual and automated scoring methods. However, findings for other variables are limited and quite mixed, and this can possibly be due to differences in severity, differences in the elicitation tasks, and differences in the measurement definitions, as well as researcher bias. So existing evidence is really quite sparse, and many studies lack automated feature extraction, and this limits comparability across methods and populations. So for future studies, we hope to have approaches that focus on patterns of linguistic distribution and move beyond that traditional error-based fluency classification. And so here are my references. Thank you for listening to me, and if you have any questions, let me know.
Great, thank you, Alec. Any questions for him? Welcome. So Chris is asking, what drew you to this research?
Well, I'm a behavioral neuroscience major, but I have a minor in linguistics, and I'm very interested in language. And so I was kind of looking at somewhere where I could kind of combine these two. And I found in the School of Communication Disorders, my mentor that I'm now working with was studying aphasia. So I got together with her and we came up with this.
And then one more, what was the most challenging part of the systemic review?
I think it's when, because all of these lexical variables have very different definitions and very particular definitions, but they're different. And so learning that and then learning to go through lots and lots of different papers and extract only the information you need. Because although these studies did not include the information, did not necessarily include enough information about these lexical variables, all of them included a lot of different variables other than just the lexical. And so being able to just extract lexical variables, especially because there are a lot of different kinds of lexical variables. So you have to be able to know which variables are what and what they show. And that's a difficult thing to learn at first.
Great. Any other questions for Alec before we close up the event? No, again, thank you again to all of our presenters for sharing your research. Thank you for all of you for taking the time out of your morning/early afternoon to hear about all the great things that are going on here at FSU. So we have recorded this event, so we'll share that to all of our registrants, and it'll be on our YouTube page as well. But again, thank you so much, and I hope you have a great rest of your Wednesday afternoon. All right, thanks all.